Yes, will. And good morning, everyone. Okay. So, let me introduce myself. My name is Ravindra Bucherla, and I am working as an senior application engineer in Ansys at Aircan Solutions Private Limited. Okay. So, in this, in the first presentation, I just want to showcase how Ansys will help in the research. Okay. So, in this particular presentation, I'm going to cover few topics related to introduction about Ansys and what are the different solutions that Ansys is offering, and what are the core technologies and labs that we can develop, or in what all departments, or in what all research technologies that Ansys will help us to improve our product, or how it will add value to our research paper. So these are the different topics that I'm going to cover, and I will just add few case studies related to the different research themes as well. Okay. So as we already working on different equipments, so we'll be working on different technologies. Okay. So some people might be working on aerospace, defense, or electric vehicles, drones. Okay. So different manufacturing technologies that might be conventional manufacturing like welding, drilling, milling, or the advanced manufacturing technologies like 3D printing. So whenever we are working on any new research, okay, so what are the challenges that we will face? Okay, so generally we will go for our setup and we will execute our product, and we may get some results. Okay, but when our objective is to design a new product, or when we are working on some process, so our objective is always to get the optimized result, or to develop an optimized product or process. But one of the major challenge that we will face in the physical setup is we will not be having much parameters or much feasibilities to go beyond a set of samples, or if you want to go for multiple parameters or multiple samples, it might take a lot of time, and also it will consume a lot of product development cost as well. Okay, and we will not be getting all the results that we require, or we will not be capturing all the results at all the different points through the physical setup. So this is where Ansys will help us. And so when we are working on different technologies, each and every technology will be having different codes and regulation requirements. It will be having where we should meet that regulations. So that might be ISO codes or IP codes, where we need to meet to complete the product development. Okay, so this is where the simulation will help us to improve the product, or to add some value to our research problem. So ANSYS is one of the simulation leader, which is developed 50 years back, and so it is number one in simulation, where it will offer the solutions globally across with 6,000 plus full-time employees and 90 plus offices. And it is a proven software where we are focusing completely on the simulation, and we are achieving 93% of the customer satisfaction. So the simulation is not only something related to the structures, it offers solutions to different physics. Like whenever we are working on structures, fluids, electronics, or semiconductors, photonics, so like that, whatever the physics that we will be working on, so ANSYS offers simulation to all these different physics. And whenever we are working on a product which requires multi-physics, so suppose you are working on aerospace or defense related projects, you might need to involve physics of structures, fluids, and in case if you have anything related to the electronic components like antennas, or if you are designing on any PCB parts or battery, so where we will be involving different physics like structures, fluids, and sometimes electronics as well. So like that, whatever the physics that we need to add to our particular project, so Ansys will help us to couple one physics with another physics where we can solve multi-physics problems. So Ansys offers these different physics for different parts. Okay, so this is the complete Ansys product portfolio where we will be solving the problems related to fluids and electronics, which are like related to electrical, electronics, mechanical, civil, and all other departments. So suppose if we take structures, so basically in structures we will be working on different scenarios. So we might be working on the project where the dynamics are involved or where vibrations are involved. Okay, and sometimes we will be working on the multi-body dynamics, or we might be working on IoT manufacturing. So we might have the physical equipment, but we also need to make sure the product will perform over the period of time. Okay, and also you might get the results at a very few locations. So suppose you are working on one mission, so where the motor is there and the motor is running with some particular RPM, and your objective is to design the mission in such a way that it should withstand all the forces that are acting on the particular missions. So that might be some gearbox or some other components which are mounted on the mission. Okay, so you have to make sure your product is reliable. It should withstand all the forces at all the different scenarios. So in physics, like in experimentation, when we perform the experimentation, we might get a very few outputs. So we might see where the cracking will happen or where the structure is going to fail. Okay, so in very few locations only we will be getting all these results. But yeah, sure.
Very good morning, everyone. My name is Prasanna. So before getting into the presentation, you all should know what you are going to see today. So that will be means easy. It will ease the presentation, and also the takeaway will be better. Is what I felt. So my name is Prasanna Shankar. I take care of academic program of Ansys. So may I know anybody have worked with the Ansys tools here before? So means so it is new to you. So you are the only one. So you are from which department, Professor? Automobile department. Fine. So may I know who all are from electronics here? You can put your hands up. Yeah. Okay. So electrical, computer science. Okay. Mechanical. Okay. Okay. So you are from fashion technology. Okay. So any other department is here? Management groups are okay. Fine. So let me brief about what is simulation and why you need this tool. Okay, so means Ansys is a simulation software. So what they do with this software is any manufacturing company, either it is a aircraft manufacturer or automobile manufacturer or your mobile manufacturer, any product manufactured in the globe, they go through simulation first. So the reason for going through the simulation is to identify the product which is accurate and say example they give these days 5 years warranty, 10 years warranty. They want to cross check everything in simulation before going for a prototype. Okay, so you see nowadays when we buy a car they give 5 years warranty. When you buy a washing machine they give 10 years warranty. It is all because they have simulated it. They properly checked it. They know this product is not going to fail for next 10 years and they charge you also. This is how people who develop a product through simulation take the warranty money as a separate extra business model for them. So the simulation helps the industries in various aspects. Number one, it saves the cost. You don't want to iterate 100 materials. You will go for only one material final manufacturing. Everything you do in simulation 100 times you will do different type of solutions. Finally you will arrive the best and then you will go for only one time manufacturing. So you save material cost, then you save manpower cost, Everything happens in two computers, three computers in the system. They go for high performance computing. They parallel process it. And they ensure this product is working fine with 1,000 iteration. And they select the best iteration. It saves the cost. It saves the time. It saves the manpower. This is how all automotive customers are Ansys. Means automotive means manufacturers are Ansys customers. All aerospace, Airbus, Boeing, everybody use Ansys. Your Samsung, all the mobiles you use, Apple, all are Ansys customer. So it is there are two things in engineering. One is mathematics, other one is physics. So these two are the two eyes of engineering. Without this, we don't have any department. Means every department in lab we either will use physics or mathematics. So there are two tools. For mathematics, it is MATLAB. For physics, it is ANSYS. So it is applicable for all the departments. Then everybody know what is five elements, Panchabhuta. What is it? Air, fire, water, earth, sky. So in engineering terms, we name air as aerodynamic study, water as fluid dynamic study, fire as thermal engineering, earth as structural engineering, and sky as electromagnetic signals. So this is how. Without these five elements, without this Panchabhuta, there is nothing in the earth. Yeah, this is a solid material. So any product you develop, it's combination of two or three physics or one physics. Okay, so this product allow you to confidently develop your research, your product with high accuracy. And you can say this is means I can means it gives you a confidence for multiple aspects of product development or completely I can say IIT Madras, IITs, all IITs and NITs, they are big user of Ansys. They have 1,500 research license in campus. Every student have one Ansys license in their laptop. They claim their IPs using Ansys platform. Confidently, I can boost myself and say that NITs and IITs are big customers of us because they know that this combination of multi-physics product development happens through one platform and they can interdisciplinary mechatronics activity or 5G EV Hyperloop team we are supporting. Ansys Hyperloop means IIT Madras Hyperloop Avishkar is supported by us. They don't use any other software. They use Ansys extensively. Similarly, any Raptor. So recently there was a message Australia team is going to solar car. So that is also they are also using Ansys. Anything innovatively you see in this academia or industry, Ansys is there. So this gives you a one single platform. Say in case of say example, sir, I know MATLAB, I know some other tool, how it is compared with Ansys. One platform which will give you the complete portfolio to develop. Ansys have a workbench. It have people don't know coding also can use Ansys. So it have a 3D modeling also. It have also means like a traditional way of coding also. So that those aspects and all Ravindra will take it forward. But for you, it is something like people want to have a startup in campus. People want to have incubation center in campus. People want to have product development in campus or more research funding in campus. This is the platform. So I have seen universities like top universities like SRM, VIT, they have our campus bundle. They have 500 license. So they have given this access to their students in hostel. So how the students of IITs and VITs are different from Anna University or VTU or I'm not comparing, but how they are excelling is because of such tools given to them. So this is the platform they have. They play out of office hours, means college hours. They get access to these tools. They come up with a project, mini project. They go exposure for competition. That is how they could able to make a difference in their career. So this is something need of the hour. So these platforms, you cannot invest for every technology separate software. Your institute also will not agree for that. So better you can go for one centralized mathematical tool, one centralized physics tool. So this will be something like common for all department. Then your students can come to mechanical, electrical, computer science, all can sit together and involve in a project. Say example, your mechanical team goes for SAE competition. Similarly, electronics team go for means mobile related competition. So they need this type of platform. I could see in SAE competition every year who had excelled this, they have used the simulation. Student who have fine tuned their product on racing cars, So SAE, there is a competition always happen globally, means like across India, which students manufacture their vehicle. If you go inside of means any institute in automobile or mechanical, you can see a car parked. So this is a racing car developed by students, and they go for racing. And these students who perform well across India is being awarded for that percentage, means like whatever the vehicle they have developed. So we have seen in last 15 years who have used the simulation have won the competition. So this is one of the basic example. Similarly, for IP generation, product development is of your interest. Not only it is your PhD or MTech research. Research how you are going to impact the industry, how many IPs you are generating, is your startup is being purchased by industry. Our aspect of research should go beyond the regular research. So for that, you need these type of innovative tools to be with you. So if you now go through the presentation, it will be easy for you to understand. Thank you.
Thank you. Thank you, sir. So I would like to showcase two more slides before I come to this slide. So as Prasanna sir told, this is how our general design process or the research process that we will be carrying on. So whatever the product that we will develop, so first we will see what is our purpose of the project. Okay. So in which kind of environment the product is going to perform, and what kind of initial design, what kind of initial material that we want to consider. Okay. For that particular environment. And later on we will do the 3D model, and we will go with the prototype, and we will test the prototype by applying the loads and boundary conditions, whether that might be electronic product or structural product or CFD product. So in the testing, if that will perform well, then we will go with the production or results. If the product will fail at the testing stage, then we will do some modifications. Okay. So we may replace the material, or we may change the dimensions to improve the strength of the product if it is going to fail. So this is how the cycle will go on until we will get a product where we can rely on the result. Okay. So, but the issue or the challenges that we generally face with this process is, every time the product will fail, we need to redesign it, or we need to replace the material. Okay. So in the first iteration, you might go with some structural steel, but you may face some issue with the structural steel because of its material properties, or because of its density or weight. So you may replace that with some other material, and you just go with multiple iterations, which will lead to more product development time and cost. Okay. So this is how Ansys will help us to avoid that multiple iterations. So once we know what is our objective, what is our initial design and material that we are going with our project, so instead of directly jumping into the prototype, you can create a 3D model, and you can perform that real world scenarios by using the simulation. Okay. So suppose you are designing the antenna, or you are designing one electric motor. So what is the parameters of that motor, and what is the RPM that you are considering? Okay, what are the outputs that you want to measure? So all these results, loads and boundary conditions, everything will be done in the simulation stage itself. If it will fail, we will get to know immediately without spending much time and money. So we can do the modifications in the software itself, and again we can rerun. Okay. So this will help us to avoid to go for the prototype directly. Instead of going for the prototype, we can do the simulation. And in case if you want to improve your product, so at that particular testing stage, the product may perform well, but once it will reach to the customer after 6 months, or after 1 year, or after 2 years, the product may fail slowly because of various environmental impacts. Like it might be because of the fatigue, where the load is active on the product repeatedly, or because of some corrosion, or because of decreasing in performance of the motor. So there might be some various factors that it will affect. Okay, so we can go for optimization as well, and we will get to know what is the best parameters that are suitable for our product, and also we can predict how long the product will perform well, and after how many cycles the product will fail. So that failure rate or the number of cycles at which the product will fail. So this information also we will get at the simulation level itself. So once we complete 500 iterations or 100 iterations, then out of 100 or 500 iterations, we can select the best sample and we can go with the prototype. Okay. So once we complete the prototype, we can do the experimental verification and we can validate our results with experimentation and simulation results as well. So this will help us to identify the results over different aspects. So instead of going with only one aspect, that might be you might be interested to see the failure criteria or what is the maximum strength it can withstand. So instead of going with only one aspect, you can explore different aspects by using the simulation. Okay, so it will overall reduce our research time as well. So instead of spending more time at the experimentation, we can do that in the Ansys itself, and whatever the product that we will finalize. So those dimensions only we can consider for the experimentation. Okay, so whatever the failure iterations that we generally face in the experimentation, so the complete iteration we can avoid by using the simulation. And this simulation will help us to the product code regulations. So there will be so many, product code regulations based upon the product that we will be working on. So suppose you are working on a battery or you are working on some electronic device where it need to have the product code regulations like IP69, 68, water and dust resistance. Okay, so that kind of product code regulations also we can meet by using the simulation. We can do water resistance test, whether the water will enter into the product or not by using multiphysics. Okay, or what will be the maximum performance, like how long the product will perform well, whether the product is reliable or not, and if there is any cause for the failure. So the product may fail in future because of thermal issues or because of improper material, or if you are using bolt and nuts or seals or any mechanical equipment if you are using, which particular part in that assembly is triggering to fail. So because of the sealing or bolt and nuts that might lose. Okay. So what is the root cause for the failure will also we came to know by using the ANSYS simulation, and overall it will reduce our product development time and cost. Okay. So this simulation will work for all the physics. So whether we are working with a part which is related to the mechanical or fluids related thing, like if you are working on any heat exchanger or you are designing the aerodynamics of the car or any rocket. So if you are working on any electronics related equipment like the motors, EMI, EMC, PCBs. So whatever the product that we will be working on, which is related to any department, that might be chemical department, electrical department, civil, mechanical, aerospace, defense, okay, aeronautical. So whatever the product that we will be working on, ANSYS provides simulation to all the products with taking multi-physics. Okay, so we can solve the problem by using different physics in a single product. And and another major challenge that we generally face is once we design the product, we might not have different materials that are available. So we will be having a limited materials, maybe some 300 materials or 350 materials, which we can directly take and use for our research. So in case if any new material is developed by any other researcher, so that material properties, that material strength and all, we not get so easily. And also if you want to take five or six different materials, and you want to test your product, which material is suitable for your product. So to do these kind of material research also, we have some separate tool called Granta. So this material Granta tool, basically it will be having nearly 4,200 plus materials. So as you already know that the material scientist Ash by, okay, most of the mechanical and material science people might know. So basically, based upon what requirements we have. So suppose you are okay. So suppose you are designing one aeroplane wing, and you want to select a material which is suitable for aerospace applications. It should be lightweight and it should have enough strength so that it will not break when it is flying. Okay, and also we have to make sure that it is not much flexible so that the wings will deflect more when the wind load is acting on it. So based upon these parameters, how you are going to select a material which is suitable for your application. Yeah, so
Is it possible to show the structure? Sorry. Yeah. Zone those parts. Okay.
Star rating. It is all possible. It is all possible because of this simulation and material selection and also structural engineering. Coming to the left side, embedded software and digital twin. So this is more related to electronics and computer science department. So we have a tool called SCADE. This is a Aero standard tool. Any aircraft industry want to manufacture aircraft, they should go through SCADE tool for cockpit design, because this cockpit design should be in real time embedded control. So example, if something goes wrong, the control should be happen in fraction of seconds. So there is a ISO standard followed by aircraft industry. Similarly, ISO standard is followed by automotive industries, followed by nuclear power. There is some seven standard machine means life of human is very important, like on the product development. They follow these ISO standards. So anybody you are developing your students in embedded domain in C, Java or C++, you can also ask them to go through this ISO standard embedded software. It is these tools are available as a student license in our website. We have 820 free courses also available on this products what he is explaining today. So it is a half an hour, 15 minutes courses. You can go through the video, you can open the software, you can run through it, and you can evaluate yourself. So everything is freely available in the website. But when it comes to bigger size problem, bigger size means like IP generation, product development or research, you need authorized license. But to start with, the student license is enough. But it have a node limitation. So this is about embedded software. Similarly, in semiconductor, we have a tool for sign off. So signal power integrity in chip. Say example, there is a VLSI flow. People who knows VLSI flow, they know cadence, synopsis. These tools are means useful for ASIC chip manufacturing. When the chip is being manufactured, means before going to the foundry, you want to check the chip level signal and power problems. So that is being carried out by Ansys Semiconductor. We are part of MIT Ministry of Electronics means Ansys tools of semiconductor is also incorporated. Similarly, like we have few tools related to digital twin, we can replicate the product and we can do predictive maintenance in digital twin. We have a tool called STK. It is for satellite communication. So we can do the arbitrary simulation of satellite. So which orbit it will go through and how it will reach the moon or Mars. So there was recently like Chandrayaan 3 was not the regular route. They have taken a long route to reach because of some obstacles in the space, and they had implemented ANSYS SDK. For this, SDK is a satellite communication software, and you can build the orbit of the satellite to reach the different locations in the space. It is used by IIST Trivandrum, ISRO subsidized institute for space study. IIT Madras students are also using this for student satellite project. I could see 100 colleges had been identified for student satellite mission. So this is one of the right tool for that. And we have another tool called optics and photonics. So these all the acoustics tools are there. This is for vision and for vision we use optics tools, and for acoustics is for hearing purpose. So anything on autonomous vehicle, drones, means unmanned vehicle, you need this technology. And also for photonics is for quantum mission. I could see 15 institutes in the country have been identified for semiconductor and quantum mission. So quantum is the topic which is on high demand miniaturization of the chip, and ANSYS is into quantum through numerical software. So this is various technologies related to various departments. So you want to identify what is your research area, you can reach out to our experts. You can ask them like, this is my research domain, you have something related to us in ANSYS. So we will help you to identify the right product. This is combination of 55 softwares. It is not one software. So you can choose what is the exact requirement for you and reach out to us. It will help you to go through your research. We have a lot of learning aid. We have free softwares. We have 800 plus free courses. So you can ask your students to means like if you have internal marks, you can ask them to go through these topics which is of your interest. Please carry on. Next slide.
Okay. So whatever the tools that we have related to different physics, so we can also integrate these tools with Python or Ansys AI itself. Means, as you know that sometimes we might need to customize our own process, and we want to include any Python scripting, or if you want to include Ansys, artificial intelligence or machine learning, or if you want to go with as we know that we will be using ChatGPT a lot. So similarly, we have Ansys GPT as well. So these are kind of Ansys intelligence, artificial intelligence, and machine learning platform is also available, and we can go with different ecosystems to solve the problem instead of using hardware. If you want to go with Amazon website to submit your job and to solve the problem, so like that we can integrate our Ansys tools with artificial intelligence, machine learning, and we can also use the Ansys cloud platforms. Okay. So in depth, we want to like explore. So as we discussed, we will be working on different physics. So especially when we take fluids. So in fluids itself, we will be having different kind of problems. Okay. So sometimes we want to optimize the aerodynamics shape where the flow is over the surface of the any aircraft, or if the water is flowing through a pipe. So if you want to explore what are the different temperature distributions, or if you want to see the cavitation where there will be bends, pipe bends, and if you want to work on different fluid related general purpose applications, so we will be using the Ansys Fluent. And similarly, if you want to work on turbo machinery or any rotating objects where the fluid will be flowing inside the rotating objects, so if you want to see the mixture of the fluid and different properties like temperature, pressure variation, okay, and temperature distribution and all, so that kind of rotating for that kind of rotating objects, we will be using the CFX or turbo machinery tools. And similarly, if we have a product where there is an involvement of particles like soil or some small particles like tablets. So for this kind of applications, we will be using Rocky. And for internal combustions like IC engines, pumps, valves, compressors. So for this kind of applications, we will be using the Fort. And if you want to simulate the problems which are related to the chemical composition, like if two different chemicals will combine to get a new formula. So for that kind of simulations, we will be using the Chemking Pro to see the chemical reactions and all. And Pensap Ice is a tool which is designed to simulate the ice related simulations, like when the rockets or airplanes or any electronic components which are flying at very high altitude. So generally, because of high altitude, there will be ice formation near to the electronic components. So here we can see whether that electronic components are going to fail because of ice accretion, ice cracking. So all these related simulations we can perform by using this Pensap ice. And Insight is basically to see the results for the post processing of this Fluent CFX rock and all. Okay. And we have thermal desktop to perform all related thermal simulations which are related to electrical and CFD. Okay. And similarly, the structured products. So basically, structures are nothing but solid objects. So whatever the product that we will be designing, which is made up of a solid objects. So if you want to test whether that part is going to fail when it is subjected to loading conditions or it will sustain well. So for this kind of complex FEA simulations, we will be using the structured products. So we have Ansys Mechanical and LS Dyna, which is general purpose solvers. So basically, if you are designing any component, so if the component is subjected to force like some 1,000 newtons, or it might be subjected to vibrations. So the vibrations might come from motors or wind loads, or even if we are designing any part which is in an automobile, if the vehicle is moving on the road, because of road bumps also we may experience some vibrations. So whether the product will perform well for these scenarios or not, we are going to test by using this mechanical tool. And LS Dyna is an explicit solver. So when we are working on any aerospace or defense related products like impact, like if you are designing on bulletproof related vest or glass. So if you want to see the strength of the bulletproof vest or glasses when the bullet will hit that particular part. So at which particular velocity when the bullet is traveling, whether the glass will break or it can withstand, or if you are working on any explosion, blast. Okay, so these kind of simulations we generally perform by using LS Dyna. And when it comes to manufacturing related simulations, suppose we are going with some sheet metal operations like forming, stamping, bending. So these kind of operations. So which thickness of the sheet is suitable to perform this manufacturing process? So when we do the printing or forming operation at corners, is there any failure or not? So we will be performing this ANSYS forming simulations to get that. And similarly, if you are designing any missions or mechanism. So suppose if we take excavators or JCBs, so when the JCB is performing, digging operation, like if it is digging the soil and loading to the truck, so at what are the different force reactions, torques, or whether the parts in the JCB will fail or not when it is digging the soil. So all this kind of analysis we will perform by using motion. And Sherlock is a tool which is designed for PCBs. Okay. So as we know, we will be having motherboards or PCBs in all the electronic components. So suppose if we take laptop or a simple tab which is mounted in the vehicle. So when the vehicle is moving on the road, the vehicle will be getting different kind of vibrations. So because of these vibrations, the PCB which is inside the tablet, which is mounted to our automobile, will fail over the period of time or not. So in the motherboard, we will be having multiple components like resistors, capacitors, okay, some semiconductors, chips. So there will be multiple components. Whether these parts will fail when it is subjected to vibrations or not, we will be testing by using Sherlock. And similarly, IT manufacturing. So when we print the part by using any 3D printer, that might be metal 3D printer by using laser powder fusion, sintering, or binder jetting. Okay, so whenever we print the part, we may face some issues like the supports may fail or we may get high distortions, means the deformation is more when we print the part. So these kind of challenges will be addressed by using Ansys Additive Solutions. And Autodesk is another explicit solver like to test the parts, blast, impact, okay, explosion. So these kind of simulations we will perform by using Autodesk. And encode design life is basically to get the fatigue life. So suppose we are designing the laptop hinges. So basically when we open and close the laptop, these hinges will perform well. But continuously if we open and close your laptop for 1000 cycles or 1 lakh cycles, so at one particular period of time, the laptop hinges may break. Okay. So this Ansys encode design life will give the solution at which particular cycle the laptop hinge will fail. So if you open and close your laptop for 50,000 cycles, means 50,000 times if you open and close your laptop, maybe after 50,000 cycles, the laptop hinge may fail. Okay, so this encode design life will give the product lifetime. So any product at like what is the safe life cycle, and after that life cycle at which particular time the product will fail. So this information we will be getting by performing the fatigue analysis by using encode design life. Okay, so similarly we may use different materials. So sometimes we might be using aluminum, structural steel, and copper for our different products. So this material product collection, which is having different products in the materials, will help us to identify which material is suitable for our product. So suppose here, if you are going with structural steel, okay. So if you want to know whether the product is performing well, suppose if we take the same example of the hinges. So if the hinges are made up of structural steel, so what will be the life? And if we replace the structural steel with stainless steel or some other alloy like brass or aluminum, so what is the difference in the performance? So if the structural steel will fail for 50,000 cycles, whether the aluminum will increase the life or it will be less compared to the structural steel. So this kind of material analysis also like we can perform by taking the different materials. And also one of the major challenge that we generally face, while developing a product is sustainability. So as we know that sustainability is also a major factor that we need to consider for whatever the product that we will be developing. So if you are selecting a material, throughout its life cycle, it will consume a lot of energy and it will give a lot of carbon footprint as well. So suppose we are manufacturing hinges with structural steel. So if we take the life cycle of the structural steel, so generally it will, we take the raw material and we use some manufacturing technology like forging, casting, this kind of thing, and we will convert the raw material into hinges. So once we manufacture the hinges will be transported from the manufacturer to suppliers, and again it will be transferred from supplier to the customer, and again it will reach to the customer. The customer will use for a period of time, and after that the product may recycle or it will go to the landfill. So during this entire life cycle, what will be the carbon footprint when we extract the material from raw materials, and what will be the carbon footprint when we manufacture the part, suppose by using casting, and once the casting is done, when we transport that material or product from plant to the vendor. So the part may travel from like one place to another place by 500 kilometers. That might be through train or some airways, or we might use some trucks. So during this transportation stage, what will be the carbon footprint and what is the energy consumption? Okay. So once it will reach to the customer, at the customer level, what will be the carbon footprint and energy consumption? So, so like that, if you are considering structural steel, it might give some value of carbon footprint and energy consumption. So similarly, if you replace with structural steel, maybe if you use copper alloy, so that material might have different carbon footprint and energy consumption. So we can compare few materials, especially the polymers or any other materials, and we can select the best material which will release less carbon footprint and which will consume less energy. So like this also we can achieve our sustainable goal, which is a major impact for the environment. Okay, so for this particular analysis, we will be having different tools like material database, which is a basic one, and Granta selector for industry and experimentation or research level tool, and EduPack is a basically teaching version of the Granta, where we can teach the material science related topics to the students, like what is Young's modulus, what are the different properties of the material that we will be having. So all these things we will be exploring in the material section. Okay. So similarly, we have electronics product collection as well. So when we talk about the electronics, we will be dealing with different kind of applications. So we will be designing the motors, transformers, antennas. Okay, and we will be performing different kind of analysis like EMI, EMC. Okay, so for all this kind of analysis, we will be using this electronic product collection. So uh, so we have high frequency electronic simulation tool, which is HFSS, which is a general purpose solver for all 5G related simulations like antennas, EMI, EMC analysis, and we have low frequency tools which are designed to which are developed to design motors, okay, or transformers. So like this kind of simulations, and power and signal integrity on PCBs. Like whenever we design any PCBs, we will be having different components. So if you want to perform EMI, EMC analysis or power integrity and signal integrity, so like these kind of simulations also we can perform. Okay. So these are the major or four pillars of the electronic components. One is HFSS, where we will be performing the simulations related to the antenna, 5G, and radio frequency microwave components. So this kind of EMI, EMC analysis we will be performing by using the HFSS. And another one is SI wave. So SI wave is a tool specially designed for PCBs and IC packages to perform the signal integrity and power integrity simulations. Okay, and another one is IcePack. So IcePack is basically related to the PCB simulation. Suppose if we have a motherboard in our laptop, so we might see when the temperatures increase. So when we perform any any task in our laptop, so sometimes based upon the working load, the fans will automatically operate and it will generate from fluid flow. So here in the ice pack, we will analyze what is the impact of the fluid flow on the electronic components, whether the thermal results or the temperature that is generated on the electronic components are going down by operating these fans or the fluid flow. So these kind of simulations we will be performing by using the ice pack. And Maxwell is to design the motors and motors, any missions, electric missions, transformers, actuators. So these kind of electrical missions we will be developing by using the Maxwell. Okay. So like that, we will be developing on different products ranges from kilometers to nanometers. So that might be a big component which is like antenna, where covering kilometers of radius, or if it is a small photonic or silicon element. which is in nanometers. So like that, we will be we can solve the problems related to different ranges starting from kilometers to nanometers. Okay. So Ansys Connect products will take our simulation into the next level. So suppose if you want to, create a workflow. So you are designing a product. For that product, you created a workflow. So the same workflow, if you want to repeat for some other product, so that some other product is also having the same loads and boundary conditions, same environment, just the product dimensions may change or the topology may change. So for this kind of, to save your workflow, and if you want to repeat your workflow for some other product, we can use Model Center. And in case if you are not, much familiar with the simulation GUI, you just want to create a simple app where you will directly give the inputs. Like suppose you are developing a product and you are applying a force of 1,000 newtons, and you want to see the stress strain deformation. So if you are not much familiar with the GUI, you can create an app where you will change the newtons, like a load. Instead of 1,000 newton, you can apply 500, 400, and you can directly see the result by creating the app by using the Minavera. And OptiSlang is for optimization, where you can take different parameters. So once you complete the sample, once you complete the simulation for a single sample, if you want to create some 100 samples, so by using the OptiSlang, by creating a few parameters, you can duplicate into 100 samples and you can test that all 100 samples. So once you test that all 100 samples, OptiSlang will automatically give or suggest a single sample which is more efficient than the other 99 samples that we have. So like that, you can use the OptiSlang and you can pick a optimized sample out of multiple samples. Okay, and these are other three MDS, Granta Selector and Granta MI is for material selection that we discussed in the previous slide. Okay, so like that, whatever the industry strengths that we will be having. So whether it is a automobile vehicles where you want to simulate the complete chassis. Okay, so if you want to perform different crash tests or electrification, like if you want to go with hybrid vehicles like EV, where you want to simulate batteries for the complete electric vehicle or any electronic or smart connected products which are related to 5G, 6G, and if you want to include artificial intelligence or machine learning into your processor, into your research. So whatever the industry trends that we are currently having, all these simulations we can perform by using Ansys platform. Okay. Okay, so like that, Ansys will help in the engineering in all the different departments that might be mechanical, automobile, aerospace, energy, civil, electronics, chemical, electrical, electronics, and even with the normal physics. Also, we can use the simulations and we can perform the related simulations. Okay. So in depth, if you want to explore for each department, we will be taking different scenarios or physics or applications. So if you take mechanical or aerospace, we can perform all the structural analysis, kinematics, okay, impact, safety, drop test, additive manufacturing, so turbomachinery, fluid related simulations, renewable energy, manufacturing. So like that, whatever the subjects generally we will teach or whatever the research problems that we will be working on mechanical or aerospace, so we can cover all these topics by using the simulation tool. And similarly for the civil engineering as well, like if you are working on bridge or tunnels, dams, skyscrapers, or wind impacts or structural engineering. Okay, so burners, boilers, heat exchangers. Okay, so whatever the topics that we will be working on the civil engineering, chemical, biomedical, electrical and electronics. So all these topics will be covered by the simulation. So you can use the Ansys technology to simulate the same scenario in the software. So to reduce the product development time and cost. Okay. So these are some of the technology labs where we will be using the multi-physics simulations to solve the problems. Okay. So these are single physics. Like if you want to include only structures of fluid to solve the problem, so that is also possible. And in case if you are working on the multi physics, okay. So these are the current technology labs that are being developed on all the educational institutes at COEs, like 5G, electric vehicles, ADAS, smart manufacturing, UAVs, vehicle engineering, IoT, healthcare, electronics. So these are the different technology labs. Okay. So suppose if we take healthcare, so these are the different, you know, verticals where we will be using the simulations at the healthcare, like medical devices. So whenever we are working on or developing any medical devices, so we can use all the simulation tools to perform these kind of simulations, like blood pumps or MRI safeties, dry powder inhalers, or pharma and biopharma, like mixing and scale up, tablet compaction, spray drying, or even COVID-19 support related simulations also we can perform related to the healthcare. So this is related to 5G design and development solution. So where we will be using the electronic software at different level of the 5G development, like chip on package, system design, signal and power integrity, optical integrity. Okay. So to perform the RFI, EMI, cable radiated related simulations. And so if you want to see the full communication analysis in electrically large and complex environment, so how much area we are going to coverage for the signal and power integrity. Okay. So similarly, electric vehicle is one of the trend that is going on. So even for the electric vehicle also at all different levels of the simulation, because in the electric vehicle, we will be involving different physics. Okay. So suppose if we are working on any electrical missions like motors, where we want to analyze the magnetics, cooling, durability, and noise, vibration, harshness, and suppose if we take battery, so we will be performing the simulations related to the battery by including the structures. Like if you want to see the drop test, so or a nail penetration, suppose in case of accident, if any external object will hit the battery, so it will lead to the thermal abuse or battery explosion sometimes. So we have to make sure the battery that we are designing and integrating in our electric vehicle is very safe, because we see a lot of videos in online, the battery explosions or burnings, especially the Ola EV vehicles. So one of the major reason for the battery explosions is improper, research on the batteries. So it will be developed on only one scenario, but in case if there is any thermal increase or because the battery charge or discharge, if the temperature of the battery will go high, or because of some accident, if any external part will hit the battery, so because of the chemical composition sometimes it will explode. So this ANSYS will help us to simulate the battery with all the aspects by taking all the scenarios, so that our battery will be very safe for all the scenarios. The explosion or the battery failure will be very less. Okay. So similarly, we can perform the simulations related to the controls, power electronics, system engineering, and functional safety. Okay. So as we know that for every vehicle, we will be performing the crash test to get the safety rating. That is generally what we call it as HPCA, where we will be getting 5-star rating, 4-star rating. So we can simulate the complete vehicle when it is hitting any other vehicle, or when it is hitting a rigid wall, whether the person sitting inside the car is safe, or is there any damage at different areas, neck area, or head injuries, or side impact. So all this kind of simulations related to the vehicle engineering also we will perform. Okay. So yeah, another technology is manufacturing technology. So in the manufacturing also we will be working on different manufacturing technologies like metal casting, molding, metal forming, joining, finishing, milling. So there will be different process. So if you are developing a tool, suppose you are working on drill bit, if you want to know what is the life of your drill bit, at which particular, after manufacturing 5 or 6 parts, what will be the life of the drill bit, whether the drill bit is going to fail or it is going to, break that sharpness. So all this kind of manufacturing operations also we can perform by using the simulation. Even we can go for the advanced manufacturing technologies like IT manufacturing by using different powder technology or laser powered fusion, what we call, or sintering, boiler jetting. So this kind of IT manufacturing simulations also we can perform. So this is another lab related to the UAS. So whenever we are working on any UAVs, that is like drones or any small aircrafts, if you are designing. So to design an aircraft or drone, we will be simulating different aspects of the drone like aerodynamics, aircraft, aeroelasticity, control system, communications and electronics, chips, packages. Okay, so like that we will be performing different simulations. So all these different simulations can be performed related to the UAS as well. So in case if you want to include artificial intelligence or if you want to use machine learning for your research. So suppose you are working on one product, so you are developing a product, you are working on some research. Okay. So you have 4 samples, but if you want to see like whether if you go for different sample, what will be the output of the sample without performing the simulation or without performing the testing. So by using the testing, we can get the result through experimentation, and also we can perform the simulation and we will get the result. But in case if you want to avoid these 2 steps, or if you want to get the result by using the artificial intelligence, so Ansys also has solution for artificial intelligence in case if you want to avoid the simulation and testing, and if you want to directly get the result for a new sample. So you have the results of 4 sample, but without performing the simulation or experimentation, if you want to get the result for the 5th sample, so this Ansys artificial intelligence will help. Okay. So one is discovery. So by using the discovery without performing the complete simulation, after completing the design, you can directly get the results of different simulations like structures, fluids, and all. Okay. So you can see the fluid flow inside the blow valve. So how the fluid is entering from one end and exiting from the other end. So when we operate the valve, how the fluid flow will alter, at which areas we will be having the maximum pressure and which areas we will be having the minimum pressure. So like this, we can use the discovery and we can get the fast results. And another one is Ansys. So you can also use the Python language to script your research. Okay. So you can integrate the Python language with all the solvers that we have. Like for mechanical related simulations, you can go with Mechanical APDL or PyFluent for the fluid related simulations. So you can integrate the Python language and you can alternate the GUI. Okay. So now when we talk about AI, so you can use the artificial intelligence in Ansys tool in 3 different ways. So the first way is whatever the simulation that you are performing currently. So you can directly use the Ansys AI to do some modifications in your current model, or you can train your model. Okay, so suppose you are working on some aerodynamics of the vehicle. So you have 3 tests. So you can integrate that 3 test results into your sim AI and you can get the result for the 4th design without solving or without simulating. You can directly get the 4th result. So just like we use Chat GPT, you can also use the Ansys GPT for any to get any information, to get any tutorials or suggestions for your project, which kind of loads and boundary conditions will be suitable, or do you need to do any modifications. So like that, you can use Ansys GPT as well. Just like we use the chat GPT, you can type and you can ask whatever the queries that you have, and it will give the guidance in terms of text, videos, or the live simulation that we will be performing. Okay, so I will showcase one simple example how this Ansys artificial intelligence will help us in our product development. Okay, so suppose you have the result of different designs. So on the left side, you can see these are the different car models. So you have uploaded 4 different car model aerodynamic result. So once you upload the data, you will train your model, and if you give any new model which we don't have the result, so based upon the previous data, based upon the machine learning, it will automatically give the results. Okay, so 4 results we will upload, and we will upload the 5th model which we don't have the result. So this artificial intelligence will give the result for the 5th model. So this is how you can train your model by giving the past data, and you can give or you can generate a result without performing the simulation or test by using the artificial intelligence. So this is what the tool name is SimAI that we call. So like that, you can include the artificial intelligence also in your project. So that might be any physics or any you can use the SimAI. So it is applicable to all different physics. Okay. So we can use this different artificial intelligence tools for fluids, structures, electronics, optics, and all. So this is one of the case study related to the aero performance. So you can see these are the SimAI results. Okay. So these two are the results that we are getting from the simulation AI, and these two are the results that we are getting from the tool using Fluent. Okay, you can see these are the SimAI results. Okay, these two are artificial intelligence on the left side, and these two are the simulation results on the right side. So the Fluent and SimAI. So this is how close we will be getting the results. So here also we can compare the drag and lift forces by using the SimAI and the solver. So what is the time? Yes, sir. We'll continue for 15 minutes, and after that, some other person will do it. I will close in 15 minutes. Yes. Okay. Okay. So we'll take a quick break, and we will continue like after the break. Okay. Okay. So, yeah. So we'll continue. So this is one of the case study that we discussed. So the variation in the results of sim AI, artificial intelligence, and the fluid. Okay. So similarly, this is one of the case related to the thermal management of the battery. So during the charging and discharging, so how the temperature generations or the heat generation within the body, like if you want to simulate, so this is how close we are getting the results. When we compare the results of artificial intelligence and fluid solver. Okay. So this is wall temperature on the battery model. So like that, we will be solving different kind of problems. So I will just showcase few examples and few applications and case studies as well. Okay. So these are the overall different applications related to the structures. So structures is nothing but whatever the solids that you want to simulate. So when the structure is subjected to different kind of loading conditions, like a simple force, what we analyze as strength analysis or vibrations or manufacturing related, even if you are using any composite materials. Okay. Or if you want to see the durability or rigid body dynamics or applications related to the blast explosion. Okay. So like that, we will be solving the problems by applying the whatever the real scenario. So we will be applying the same loads and boundary conditions, and we will be checking what is the critical region where we will be having the maximum stress, or in which particular region the product is going to fail. Okay. So similarly for the civil related applications also we can use the simulation software at different applications. Okay. So in case if you want to complete, if you want to simulate the complete assembly, so okay, even the crash test or side impact. So this kind of simulations also we can cover. We can simulate. So instead of directly going to the prototype testing, okay, so where it will give the exact results. So these are the CFD related applications related to the turbo machinery, compressors, IC engine combustions, okay, heat transfer. So rotor propeller related simulations. And these are some external applications, external fluid flow applications. So where the fluid is flowing around some tower, and so the fluid flow inside the tunnel, and fire simulation examples. So when there is a fire, if you want to see how the smoke is generated, and how the smoke is escaping from different locations. Okay. So this is explicit dynamics, like and this is the kinematics, wind loads. So how the winds are acting on the buildings or the towers. So where we will be having the maximum pressures. Okay. And if we take the PCB inside our laptop, so when the fans are working, how the fluid will flow inside the laptop, in which particular vents the fluid will enter, how the thermal management inside the laptops, or offshore applications, if there is any platforms, offshore platforms over the sea. So what kind of loading or what kind of stresses it will be generated because of the sea waves here. Okay. So these are different structural applications like so when the bridge is like because of the wind load, what will be the effect on the bridge because of the wind load or industrial smoke? Okay, and so these are different applications related to the biomedical. So if you want to analyze any biomedical applications and if you want to see the strength or the fluid flow inside that particular analysis, and we can also simulate the biomedical applications. And this is the fluid flow related simulations. And these are some electronic applications related to the motor design, solenoid, transformers, microstrips, waveguides, antennas. Okay, so eddy currents and so these are the high frequency tools, like how the antenna placement, what will be the coverage of the antenna. So if you are having any small antennas in our mobile also, what will be the impact and the coverage of small antennas here. So these are RF controls in aeroplane. So these are filters, autonomy, signal and power integrity. So this is how we will be getting the results as an output once we solve the problems. Okay. So here Ansys provides a different kind of licensing. So if you want to teach the software to the students where it will get with 4 cores, and in case if you want to use the software for research purpose where you want to solve your experimental problem and if you want to validate your results with the software also, we will be having the research version which is available with 16 cores, 4 plus 12. Okay, and Ansys also provides the campus license with including one HPC packs which will cover 64 cores. Generally, this HPC pack will give us benefit of solving the problem within a short period by using more number of cores in our software. Okay, so I will. Okay, so these are different success stories of teaching, research, and student teams. So I will showcase the research. Okay. So these are different success stories of research. You know, this is a story of a safety related to the person who is sitting inside the car. So instead of going for the prototype by using a dummy, so they simulated by using LS Dyna. Okay, so this is done by Jalal Maheshwari at CHOP. Okay. So this is also one of the success story related to the factory in a box simulation where they want to analyze the drop size from the inhalers. Like so this is so in this simulation, not only the solver, so they have used Pi Fluent as well. So they integrated the fluid analysis along with Python software, and they use artificial intelligence to get the result. Okay, so over 2000 simulations they have performed within 2 to 3 days. Okay, so by using the PyFluent and Ansys intelligence, they have performed like 2000 simulations, which is not at all possible if we go with the experimentation only without the solver or simulation. So this is done at Cornell University by Rahul Ghosh. Okay, so this is also simulation related to the CFD of predicting and deterioration of the ancient time archers. So this is diving into function with fluid dynamics. So where they are simulating when the diving is done, like what kind of pressures that are acting on the body and how the fluid flow will be there around the object. So so in case so in case if you are new to software and if you want to learn different physics related to the answers, we have different learning resources. So majorly we have 4 different platforms. One is Ansys Innovation Courses. So Ansys Innovation Courses is a free platform that is available in the website, which will cover nearly 8,870 courses. Okay. So all these courses are completely free. So based upon our applications, we can reach out to that site and we can search what are the applications related to our work, and we can explore that lectures. So there will be lectures and working examples. So you can download that examples and you can rerun the same problem in your laptop also. And in case if you are working on some research, topic, you can also check the Ansys learning form where people will be discussing in the learning platform, like if they are working on any new topic, if they face any issues, or if they want any help from the other researchers or Ansys developers. So they can directly post the questions, or even if you are a researcher, if you already done some work related to that topic, so you can also answer to the question that is posed by another researchers. So this is a common platform where we can post our questions, and you can also answer the questions if you have done some work related to the topic, how they can use the answers, or generally what is the suggestible way to simulate the problem of that particular physics. Okay, and especially for the students, if they want to include the skills. Answers are related to skills in the resume, and if they want to post in LinkedIn, so we also provide badges and certificates for the students by using these innovation courses. So they can log in and they can pay some fees to get the badges and certificate from the Ansys, where they can directly post in the LinkedIn, and they can add all the skills into their resume for any opportunities in the industry side. Okay. And there is one more site, Ansys Educator Hub, where for every quarter there will be multiple live training sessions will be held. So you can get the Ansys Learning Hub or Educator Hub, and you can participate in the training programs as well, which is conductable globally across all the world. So the trainings will be done by different countries, sometimes US, China, India. So the training programs also you can attend by getting the access of this Ansys Educator Hub. Okay, so these are the different content that is available in the Ansys Educator Hub. So if you are working on structures, fluids, electronics, materials, automotive, aerospace, bioengineering, STEM, environment, sustainability, so it covers all the topics related to that, even including Python and Ansys artificial intelligence, machine learning. So all these programs will be included in the Educator Hub. So you can log in and explore. And as a fresher, or if you are new to Ansys, you can also explore this Ansys innovation courses, which is nearly 820 plus courses are available related to these different physics. Okay. And 45 plus free learning tracks also available in the same site, Ansys Innovation Course or Ansys Innovation Hub. Okay, and these are some public license learning forms where we can discuss our problem or get help related to our project. Okay, so just like Chat GPT, you can use Ansys GPT as well. So you can write your query or whatever the information that you want to get. So you can write and so Ansys GPT will automatically give all the content, video lectures, or any paper that is published in Ansys platform. So that all information you will be getting from the Ansys GPT as well. Okay. In case if your institute is participating in any student organizing teams like Baha, so in Baha also there will be different competitions that will be held related to FEA sustainability. So uh, for this support also you can reach out to us for any student team sponsorships or involvements. Okay. So overall simulation is the key enabler to all the academic success. That is in terms of teaching, research, or even if you are collaborating with any organizations like DRDO or any other organization where you want to get funds and you want to develop a product using physical and simulation results as well. So nowadays, most of the professors are working with DRDOs and they are reaching out to us for simulating their problem. So we are working closely together with all the IITs, NITs, and some of the major universities for research funding and simulation related to the research. Okay. So next, my colleague Jay Krishna will do some presentations related to the optics and uh, GMAX.
Hello all, a very good afternoon. I hope Ravindra has given you insights on how Ansys tools can help you in your research and how it can accelerate your research. I hope he has given valuable insights. So thank you, Ravindra. So before starting this session, I would like to start with a simple question. So how many of you are aware of this optics and photonics? How many of you are doing research in optics or else in photonics? Okay, one. So I try my level best to keep this presentation much more engaging to all other researchers as well. So optics, you might be heard of it. It's a very common term, like it involves lenses, mirrors, reflection and diffraction, some of the basic concepts. So it all involves light only. Photonics is actually a branch of optics, but it deals with more advanced level, in the nano level. So when we are talking about the optics, light behaves differently. So light is an electromagnetic wave. It is the fastest thing in this universe. So when it is interacting with matters of different sizes, for example, if it is interacting with a nano object, it behaves differently. It will exhibit phenomena like plasmonic activities, polarization, some other phenomena it will exhibit. But in the case of macro optics, like larger objects, when it is interacting with lenses or mirrors, it will behave simply, like either it will reflect, it will bounce back from the surface, or else it will refract. It will transmit through the mirror or lenses. So for understanding these different phenomena, we have complete photonics for complete solution. So which will come under this optics and photonics. So just a minute. Yes. So in this session, what are we going to do is I will start with the what are the challenges today, like optical engineers and photonic engineers are facing, and we'll start with this fundamental software solutions to optics and photonics. Then the workflow from component level to the system level simulations, and some of the key applications where we can employ this Ansys optics and photonics tools. And we'll end with a case study. And what are all the available Ansys contributed resources? I hope Ravindra have already discussed that, and I'll add something more to it. So optics and photonics are everywhere. So starting from your mobile phone. So this projector, this is because of optics only. So you can see the image clearly. This is because of proper arrangement of lenses inside this projector, and we have illumination system light and your displays, mobile phones. So the specs that I'm wearing. So everything is optics, and photonics are everywhere. So one such example I can give you, you may hear about this James Webb Telescope. So which is actually simulated the optical components of this James Webb Telescope has been done by ZMAX, which is one of the Ansys optics products. So in today's environment, there are a lot of challenges, specifically for optics and photonic engineers. So the challenge are nothing but it is actually has to achieve the uh, optical design in an advanced form with high precision. So these goals are very much important for delivering high performance optical systems, especially in various sectors. Some of the sectors are like healthcare, consumer electronics, automotive, aerospace and defense, and even in data centers. So one of the challenges are designing optical system at high precision. Because like we cannot make any ideal optical system, right? Like whatever we are doing, so there will be some less precision will be there. So designing an optical system with utmost precision is one of the challenges. So next is aberrations in image quality. So you can see this image clearly, right? So if you can't able to see this properly, so that is one of the challenges. So whenever you're developing an imaging system, so let's say you have to take some lenses and you have to put it together. You have to make it an array. You have to put it in an arrangement, and then it won't immediately give you the best image quality. For that, you have to do the optimization. So of course, it involves aberrations. So how can you negotiate that aberrations and other problems? So that you can do. So that are some of the challenges. The next thing is material selection and properties. This is one of the most important thing. So as you are aware, silicon is the most widely used material because of its broadband. Even in electronics, it is the most widely used component. But nowadays, researchers are looking for like alternate materials as well. Because silicon is kind of like it attained its certainty. Like we cannot like even nowadays mobile phones are like what are they promoting? They are not. There is no improvement at all. So the actually the process is getting reduced by the size of like 4 nanometer. That's it. But there is no improvement. Either they are coming up with rollable displays or foldable displays. This is because like they are attaining the saturation point. So it is at utmost need that we have to look for new materials and properties as well. So one such material that we can say in recent times, I hope you have heard about this meta materials. So those are some of the materials like, and then thermal and environmental factors. Because whenever you're designing an optical system, it has to operate in different conditions. So let's talk about this lasers. So lasers are high power lasers are actually having high energy beams. So these energy beams can actually be affect your optical systems like lenses because of this high energy beams. Apart from that, in aero optics, for example, how many of you have watched this film called Top Gun Maverick? So there they have to travel over this different harsh environment conditions, but they have to locate this enemy aircraft, then they can destroy it. So these kind of thermal and environmental factors are there that will affect your optical performance. So that is one of the challenges. How can we negotiate that? So that we can do that. And optical simulation and modeling, that is one thing. And then miniaturization and integration. So this is the most important thing. So whenever you're talking about this optical sensors, so nowadays people are trying to integrate in health things. For example, in mobile phones, and one thing is our smartwatches. We can see there is a light blinking at the backside of our smartwatches, right? That is nothing but it's an optical sensor. So people are trying, so researchers are trying like how can we much miniaturize these optical components into further small levels, and how can we integrate it into another electronical components. For example, photonic integrated circuits. So these are the recent advances are going on photonic integrated circuits. You may aware of this integrated circuits, which are in which for a specific application, so we have to make different circuits like for example 808 for microcontroller is there. So in that microcontroller you'll be having different electrical components like transistors, diodes. Different electrical components will come together and will perform a specific task, and that is called an IC, integrated circuits. But photonic integrated circuits are nothing but, here we'll, instead of using this electronic components, we'll be using photonic components like waveguides, fibers, grating couplers. These kind of components we use. Why we need to use this? So whenever we are using ICs, the lifetime of ICs are like very minimal, because heat dissipation will be there because electrons are traveling around these ICs. It will affect your IC interconnects. So that all these things will happen. But when we're talking about this photonic integrated circuits, where we instead of using electrons, we'll use photons. It's nothing but it's light. So light travels at the fastest pace. It will travel at very higher speed than electrons. So the your processing will be faster, and it opened a new possibility in quantum computing. So that is one more thing. So the next thing is manufacturing and assembly tolerances. So this is which is related to an ideal system. So there is no ideal system in this world. So whenever you're manufacturing or developing something, so there will be some tolerances. So there will be some problems associated with that material or with that an optical system. So what are all this? How those manufacturing and assembly tolerances are actually affecting your optical system? That is one of the challenges that the researchers are facing now. And finally, cost and time constraints. So this is the most important thing. Unlike electronic structures or other solutions, optics and photonics are the new and emerging technology. So developing a simple silicon waveguide is very much costly in developing an IC, electronic IC. So that is one more thing that we need to focus on. So these are all the challenges, but apart from the challenges are not only limited to these that I have mentioned here. There are many more challenges. So in order to avoid these challenges, we Ansys provide three solutions. So Ansys Numerical, Zemax, and Speos. So Numerical is for as I started the session with two different optics, right? Like photonics and optics. So photonics, it's talk about like nano level optical simulations. So from nano to macro, from it's a multi-scale simulation tool. So for the multi-scale, from nano to macro, we have the three solutions. So we'll start with the nano level, which is Ansys Numerical. Ansys Numerical is a photonic component level simulation software. So with this Ansys Numerical, you can able to simulate waveguides, optical fibers, LEDs, and most of the sensor optical sensors involves detectors. So those detectors are like one such detector is called CMOS image sensor. So we are using digital cameras nowadays, right? So a camera is having a lens, so a display is there, and so that optical that the lens is carrying, it is converted into the electronic information. So that is actually happening because of a sensor called CMOS image sensor, complementary metal oxide semiconductor sensor. So that sensor you can simulate with this numerical. So that nano components you can effectively simulate with this numerical. So next, from nano to the macro optics. So whenever we're talking about the nano optics, so their light behaves differently. We have to consider light traveling as a wave instead of light traveling as a straight line. So there we have to employ Maxwell's equations. So all these things your software can do. The only thing you have to do is you have to design the structure, assign the material properties, and then you have to analyze it. So next is the optical design engineering. So it's nothing but whenever we're talking in optics, whenever we're talking about optical design, it's nothing but it's an arrangement of lenses, mirrors, prisms, and all those things. So with the help of Zmax, what you can do is you can able to design an optical design which involves lenses, mirrors. So whenever we're talking about imaging, So Zmax is the go-to tool. Like you can completely simulate the camera with the help of Zmax, and it has like you can do the validation and you can do the assembly and manufacturing tolerances as we discussed earlier, and you can do the mechanical tolerance analysis as well. So inside Zmax we have additional tool as well, and then finally Ansys views. So when we are talking about this from nano to the macro level, so initially nano components, which are very smaller components, and then macro level, which involves mirrors and lenses. But now I have designed a camera. Let's talk about how to integrate it into other things. Let's say example in front of the car dashboard. So due to that environment, like since it is inside the car dashboard, so it has to counter the reflections which is happening at the windshield, and also inside the car it will be darker. So the performance has to be better. So these kind of advanced level simulations like a system integration, human vision, and all these environment integration, you can do it with Ansys POs. So these are the three tools that we have. So let's talk about numerical. Within numerical, we have Ansys numerical FDTD. So Ansys numerical FDTD, I hope you have heard about this FDTD, full time, so finite difference time domain method. This is a widely used method for optical solving Maxwell's equations. So this is the gold standard tool for nanophotonic devices. So in FDTD, you have two more solvers, which is called STACK and RCWA. STACK and RCWA solvers are like for specific applications. So STACK is for, as the name suggests, if you have multi-layer structure like distributed drag reflector, it's a multi-layer structure. Or some LEDs are like also multi-layer structures. So for that kind of multi-layer structures, we can do STACK. Or else like if you want to only change the length of your optical component, for that RCS will be a good option. The next one is numerical mode. So mode is nothing but it's a solver. So whenever we are trying to couple a light into a waveguide, so the light is actually transferring inside an optical waveguide or so based on this simple phenomenon called total internal reflection. So but there will be different modes. Modes is nothing but so it's a ways of how light is transporting inside a propagating inside a waveguide. So different modes can exist. How can we analyze that modes? Which mode will be the better one? So those kind of analysis you can do it with the Ansys numerical mode, and we have numerical multiphysics tools as well. So which involves three solvers, which is called charge, DGTD, and FEEM. So FEEM is nothing but it's an alternative for FDTD. It's a finite element tool. That's a finite difference time domain solver. It's a finite element solver. It's a most commonly used solver in other physics. And DGTD is specifically for plasmonic applications. So when we are talking about the plasmonic applications, so we need to discuss about this skin depth. Skin depth is nothing but like how if the skin depth is too small, you will get a better plasmonic activity. So that we need to work on that as well. So that we can do it with these solvers. And one more important thing is solar cells. So solar cells is a best example of this optical multiphysics. So when sunlight hits on the silicon solar cell, so there will be heat dissipation because of the long exposure to the sunlight, and the light energy is actually converting into an electrical energy. So it involves thermal, electrical, and optical things. So this is what we're talking about in numerical multiphysics. With the help of numerical multiphysics, we can do some electro-optic modulators, phase shifters, then solar cells that you can effectively do. And so we are using simulations to accelerate the research performance, right? Like to accelerate our research, to speed up our research. So apart from that, like we have GPU and HPC compatibility to accelerate your research further. And we have Ansys numerical interconnect, so which is a photonic integrated circuit solver. So you may aware of this electronic integrated circuits. These are conventional ICs that we are using in our mobile phones, laptops, browsers, and everything. So nowadays, researchers are working hard to integrate optical components along with the electrical components to improve the performance. Thereby, they are paving for different new paths. Like one such thing is quantum computing. So we can increase the speed of this computing by employing this photonic integrated circuits. So Ansys numerical interconnect is actually specifically for circuit simulation, not for the component level simulation. So you can simulate all the components with other tools, But with the numerical interconnect, you can do it with circuit simulation. So next thing is this numerical CML compiler. So when we're talking about the in circuits, we need to have this foundry and like some of the libraries. So all these things we have with this CML compiler. So this is about Ansys numerical, and these are some of the components that you can do with numerical. So nanostructure, fiber optics, anti-reflection and high reflection coatings, emitters and detectors design. We can develop a metalens. Metalens is actually the key component of a endoscope. So diffraction gratings and photovoltaics, nothing but a solar cell and photonic integrated circuits. These are some of the key components that you can develop using numerical and just numerical. Next, moving on to the nano to the macro level. So Zmax. So with the help of Zmax, you can develop an optical design. Not only design, you can develop some of the systems. Some systems are called cameras. You can simulate a complete camera inside the Zmax, but you cannot do the environment integration. How it is actually performing in the real world environment, that you cannot do it with Zmax, but that you can do it with Speos. So you can design it and you can analyze its optical performance and how the manufacturing and tolerance analysis you can do with Zmax. Now, then for how can you improve the performance with these tolerances? So that we can do. So inside Zmax, we have one more additional module called star module. The star module, it will help you do the stop analysis, structural, thermal, and optical performance analysis. So whenever we are talking about a camera, so it will be having lenses, right? So these lenses has to be housed inside a mechanical component. So there will be holders. So while we are keeping the components inside this holder, so it will actually like small minute level deformation will be there. Either the lens will deform or else the alignment will change. So because of that, this will affect our optical performance. Let's say we cannot say that your camera will always you'll take photos in an ideal temperature. So there will be temperature fluctuations. Sometimes you'll go to the hills where you'll take photos. Sometimes you'll go to the deserts where you will take photos. So due to this temperature fluctuations, that will also affect your optical performance. So how can I improve it? So for that we have a dedicated module that is called star module. So you can if you have the FEM data for the structural deformation and the thermal gradients, which you can take fit from Ansys Mechanical, another tool. So then you can import directly into the star model that will give you the performance. And by doing some modifications, you can try to negotiate. So you can try to negotiate that, uh, you know, uh, improve the performance as well. So next is Ansys POs. So it's an optical system design and validation with human vision. It's a software for optical system level designing. So here you can do the mechanical packaging and stray light analysis. Stray light analysis, nothing but it's an unwanted light. So whenever you're talking about a system, like there will be some unwanted light, unwanted reflections will be there. So how can we eradicate that those unwanted light? So that is actually called stray light analysis and environment integration. That is one of the key feature of this Ansys POs. So this is an environment like here we are having some light conditions. So you can directly import this kind of environment into SPIOs and you can see how your optical system is performing. So that you can do and full screen rendering and human vision. So this is one of the most important and key feature of Ansys POs, which we are performing better than other softwares. So human vision is nothing but let's say a 60-year-old person is crossing a road. So nowadays vehicles are like they are using this white lights, not only yellow lights, they are using this white LEDs. So that white LED can cause irritation to the 60-year-old person. But for a 20-year-old person, it may differ. For a 10-year-old person, it may differ. So these kind of perception of light simulation we can do. So what we can do is once you have developed your optical system, you can test with a different human vision. So how for a 10-year human vision, how it is actually appearing. For a 20-year-old, how it is actually appearing. And for 60-year-old, how it is actually appearing. So by doing this, what you can do is it can increase the legitimacy of your, optical design and it will allow you to achieve the perceived quality. the quality that you want. So this is one of the key feature of Ansys POs, and we have a large pool of materials. So we have inbuilt materials within these optical softwares. Apart from that, like as Ravindra told, like Granta. So that is a large pool of material library which is having a large material database. Apart from that, you can also import your own materials. So nowadays, like there are different material as are there. Like when it comes to optical, refractive index is the most key component. And refractive index in older days it is actually a single like in school days we'll talk about, like whenever we are talking about refractive index of water, it is 1.33, but it is actually a function of lot. Like refractive index is a function of temperature, refractive index is a function of wavelength, it's a function of frequency, it's a function of voltage, it is a lot. So there are different models are that. Based on that, you can import your own models and you can analyze it well. And with this Ansys POs, like you can do the whole broadband simulation from UV to far infrared simulation, and it's CAD agnostic. Whoever is good at CAD, they can easily design in anything, and you can perform the optical performance. And we have dedicated sensor models for cameras and lidars, and there is a multi-physics and multi-scale workflow. So the one thing is these optical softwares, optics and photonics of these three softwares can interact with each other to develop an optical system. And apart from that, if it required, it can also interact with other ANSYS softwares like mechanicals, fluids also. And in order to accelerate the simulation, we have GPU as well as the cloud computing capability. And these are some of the basic key features: light modeling, human vision, display legibility, and we have virtual laboratory and optical designing, and day and night system validation. You can integrate the environment and machine vision as well as optical sensors for camera and lidars. So, so this is one interaction between these sensors. So on your side, like this is a nanophotonics and this is the macro optics. So whenever we're talking about the nano optics, it will involve wave optics. And if you're talking about this Zmax and SPOs, where we are considering light as rays traveling as straight lines. So some of the research key applications are camera, AR and VR, augmented reality and VR, virtual reality systems, displays, in biomedical sensing, automotives, data communications, and in quantums. So in camera, you can see different things that you can do. If you talk about camera, the complete camera you can develop with the complete optics and photonics software tools. So for lens model optimization, you have to use Emax, and for sensor optimization, like I talk about the CMOS image sensor, you can do the optimization with numerical. And for the vision analysis, how it can perform at different environment, that you can do it with the camera. So this applies to all the other applications as well. And one more thing is in biomedical sensing, you can able to model the tissue modeling with the help of Zmax. Like our skin contains 7 layers, right? Like dermis, epidermis. So those you can model. So it's all everything has a refractive index. So if you can able to get the refractive index of that particular material or like particular thing, that you can import the data into the software and you can do the optical analysis and other applications as well. So electro-optic and infrared. So there you have micro lens optimization, lens optimization, and all those things, and aero optics. So these aero optics are very much important in the defense sectors, and high powered lasers. So these high powered lasers are also used in defense as well as in the medical industry for curing, so like cancers or those kind of things as well. And heads up displays. So these heads up displays are like nowadays people aesthetics are improving. Like people are looking for a good car, not a good car, it's a good looking car. The car is good looking, so that is the first attraction. So aesthetics is very much important. Like nowadays, yeah. So these are some of the key applications. So there are some other applications as well. Like let me go through as we have very less time. I'll try to cover this within 5 minutes. So this is one thing where you can use complete Ansys optics tool for developing an endoscope. So you can see on your left. So this is the of this endoscope. So you have the meta lens here. So that meta lens you can optimize and develop with the numerical. And this is actually the complete workflow for the metal endoscope. So model verification and the optical performance analysis that you can do it with the optics CMAX Optics Studio. Then the system analysis, complete analysis, how it will actually perform inside your body. So you can develop the tissue kind of a thing, like you can assess the material property and how it is actually performing, and what is there any unwanted light is happening. That kind of stay light analysis you can do. So next is surveillance technology. So surveillance drones are like nowadays used widely. So this survey, whenever you're talking about the surveillance drones, it is a camera. So camera involves lenses. So that lens complete lens stock optimization you can do it with Zmax, and this image sensor optimization that you can do it with the numerical. So so you will get some outputs from those two softwares. You can integrate those outputs as an input into the spheres. Then you can do the full screen rendering. So these things we have done it with the Zmax. As you can see, different environment conditions in the visible range with a clear sky, how your camera is seeing the world, and in the near infrared and in the far infrared. So you can do this complete system level environment integration simulation using spheres. So next is lidar. So lidar is one of the key component for automotive vehicles, or else like automotive drones. So nowadays Tesla is there, and new vehicles are also coming up. Like without lidar, it is not at all possible for an autonomous vehicle to ride on its own. So there are key components in lidars, so which involves like lenses as usual, and then some of the photonic components, which includes waveguides, photonic integrated circuits. These are the key components, so which will help you to transform this. So the lidar will be having the electronic circuits as well. So these photonic integrated circuits will analyze this optical data, and it will help the lidar to understand it electrically, and then it will interact with the other components seamlessly. So these two component level simulation that you can do it with Zmax and Spio, numerical. Then you can integrate it with the directly with the car. Like you can develop a car inside Spios, and at different position you can place the lidar, and you can see here like in the car is traveling here, and it is trying to do the 3D mapping with help of this lidar sensor. So based on this, it will identify how far the other car is in front of it, how far the other car is behind, and it will help you to drive safely. So this is how autonomous vehicles are working. So lidar is a very important thing for that. And high power lasers. So these high power lasers are not only being used in defense, it is also used in medical technology. So one thing is LASIK is used. So LASIK is there, and as well apart from that, like we have like curing cancers, like lasers are using optical chromatography. They are using different techniques as well. So you can develop a complete laser using this one. So you can do the optical design optimization and tolerancing analysis with the help of Zmax. And you can, once you have packaged your lenses and other components of the laser, how it is actually affecting your performance. So that you can do it with the stop analysis of this Zmax. Then you can integrate it with the you can do the environmental integration and how it is performing in the real world scenario. That you can do it with the spheres. Then beam propagation due to beam propagation. This you may hear about this free space optical communication. So nowadays we are using the optical fibers, right? And if you are using the light in the open environment, it won't propagate for a long distance due to the scattering and other dense atmosphere. So those kind of things are there. So for that, how can we propagate this beam for a long distance? So one of the application is what do we say? This application is like free space optical communication. Apart from that, it has also applications in aerospace and defense as well. So for that, like we have a Motron computation. It is not our code. Motron is actually a dedicated software for analyzing this transmission behavior in a different atmospheric conditions. So you can, if you have this, you can give that atmospheric definition conditions to that Motron computation. What it will do, it will give you the absorption and scattering coefficients. You can take these coefficients and you can input the give these coefficients as an input to the speos, and you can do the propagated simulation. You can see in the ideal atmosphere the density, the energy beams energy density is not reducing, but in the dense fog atmosphere, as you can see, it is almost degrading. So how can we avoid this one? Like in the dense fog atmosphere, this will give you the analysis. Next, what can we do is we have to do it will change the optical parameters. Like either we have to do the increase the energy of the laser, or else like we have to analyze change the optical parameters of your lenses or like other key components. So based on that, you can improve the beam propagation as well. So next thing is high turbulent air optical aberrations. Like aberrations can also happen in this due to air optics. Sorry, fluids as well. Usually aberrations can happen because of this material dispersion as well as different colors. But nowadays, when we are talking about this, as I told in this Top Gun Maverick movie, so the two fighter jets will be fighting with each other. So one guy will be following the another. So he has to detect us, like before launching a missile, he has to log that person, like log that enemy aircraft. So for that, these cameras are very much important. But you know, these jets will travel at the speed of sound. So at that speed, due to the airflow, so the aberrations will happen. So because if these aberrations happen, so the aircraft cannot log this enemy aircraft, and it will lead to the we cannot launch the missile properly at the enemy aircraft, and we cannot destroy it. So how can we eradicate? How can we reduce this aberration? So that analysis you can do this with the help of spheres and Zmax, and you can create this atmospheric environment, like how airflow environment using this Ansys Fluent, which is another Ansys software. So here you can see there is an aberration happened, and this is a perfected wavefront. And I would like to end up the session with the one case study. So Waseda, there is a university called Waseda University in Japan. So there they were trying to develop a high-speed optical switch design for the LiDAR, automotive LiDAR systems. So which is one of the key component actually. As I said, like LiDAR is having a whole lot of key components. So this is one of the key components, an electro-optic phase modulator, phase shifter. So the goal is to design this with a better performance. So what they're trying to do is they have to achieve a very smaller footprint. Like the size of the device has to be very small, as well as it has to operate at a very low voltage, as well as it has to switching speed has to be faster. So these are the goals that they have taken, and with this, using this ANSYS numerical FDTD, they were able to solve this. So here you can see. So this is your optical waveguide, and these are actually the electrical contacts like metals. So as I said, like refractive index is a function of different physical quantities. So here we have, if you have the refractive index as a function of voltage at different voltages, how your refractive index vary. If you know that, if you can have the data, if you have the data, you can just import it. So based on that, they had the data, they had imported at different voltages. So you will be having a different results as well. And also you can see there is a distance between these metals, right? So what they do is they alter the distances. So they reduced it and they have increased it at different distances. They have different loss. So at a very low, when the distance is very small between them, so they have achieved a higher insertion loss. So they want to achieve a very low loss. So with this, they can find the exact placement of those metals, how much repetition has to be there, what should be the period of that metal contacts, and along with that, so they can also use charge solver as well. Like if you don't have this voltage dependent refractive index data, what you can do is you can use charge. From that you can extract the refractive index. Based on that, like you can apply the electrical current, and how you are based on the transmission or the optical other data, so you can able to identify the voltage dependent refractive index as well. Then you can use it Ansys numerical FTTD to simulate this one. So with the help of all these the numerical FTTD, what they were able to do is they were able to develop this thermo optical phase shifter with a low insertion loss at a size that they wanted and faster switching. So also were able to achieve the low ohmic resistance, so which enabled the device to perform even at the low voltage. So Ravindra already showed you different contents. So we have ANSYS students and we have the websites, and we have ANSYS innovation space, and for optics we have a dedicated optics gallery. So in this, you'll be having a different optics and photonics examples, which will help you to learn at a faster pace as well. So the website name is optics.ansys.com. and that's like you can also follow us through LinkedIn as well. So thank you. Is there any doubts? Like if you can, like you can ask anything related to optics and photonics.
Any doubts? Go online. So the online participants, if you have any clarification, you can put it in the chat box.
Yes, ma'am. Yeah.
Yeah, medical field in the sense like what do you want to do? You want to place an imaging system inside an MRI. You want to see how this magnetic resonance is affecting your optical performance. Yes, that you can do, but you have to do the multiphysics tools. Not only with optics you can do that. Yes, yes. You can simulate VR and AR with the help of this optical simulation. Oh, what? Yes, names. Games. Okay. Okay. Specific games. No, no. No, no. You can develop that system, but that we cannot do, like games and all those things.
So, and also like in case if you want to take out the thermal image, MRI scans and all, so that kind of simulations we can perform here. So, so if anyone want to discuss about the problem statement or the research they are working on, so we will be floating on feedback form as well. So in that you can mention like in case if you are working on any specific research topic, and if you want to simulate or if you want to check what are the possibilities that you can do it in using Ansys, or if you want any help from us to integrate the Ansys software in your research problem, so we are happy to help. So you can fill that information in the feedback as well. So thank you everyone for attending this session, and we thank KCG team as well. So the Society of Research, Sponsored Research and Consultancy for organizing this and inviting us as a part of the 5 days FDP. So like we would like to connect individually for your problem statement. So we look forward to work along with you in your problem. So once again, thank you everyone for giving us an opportunity to. Thank you.
Thank you all. I hope you have enjoyed the session. And I hope we have provided you enough information on how to use these ANSYS tools in your research. Thanks a lot. Thank you for your attendance as well as thank you.
Thank you, sir. So for your information related to simulation tools, hope you've all learned about the simulation tools. Ma'am, we are requesting you to take a photo session in the ground floor. So I request all to join in the ground floor. We'll just guide you where to go. Thank you, ma'am.
Yeah.